Yes, good evening everybody and my dear ESE 2023 students. Welcome to this live YouTube presentation on solution for paper 2 technical part of electrical engineering branch. We as a team with most experienced faculty in India welcome you to ACE Online and ACE Engineering Academy. So you know this is one of the most and the prestigious exam as an engineer you can ever dream of. Union Public Service Commission, and it is a #1 technical job in India as far as government job is concerned, because they enjoy the power, not only salary, they enjoy the power. I hope you wrote well. Yes, I think you wrote well, and the real hard-working students definitely they will crack, and all our good wishes and luck is there in your hand. Okay? Yes. Now this is solutions for the technical, that is paper 2 today on electrical engineering branch. Now, yes, you know, Union Public Service Commission, Sangh Lok Seva Ayog, we say, that is a prestigious service jobs. Now the weightage analysis this time, yes, compared to last year, let us carefully observe the weightage. Here we have 3 sections as I told, the fundamental common subjects, the core subjects and basic subjects, basic like maths, basic electronics, etc. Now engineering mathematics last year 12, this also 12. So he is maintaining a very good balance. Before 2017 that was not happening. But see here, this time also 12 bits. Electrical materials, we say engineering material science, last year 14, this year 13, not much change. Circuits and fields together, yes, this time 9. Okay, field theory weightage has gone drastically down. In that mostly circuits dominated. And electronic measurements, yes, last year 12, this time 13. Computer fundamentals, see sir, this is a subject where everyone should read. Computer organization, don't neglect, see here, 12 marks, which is equal to top core subject. Then basic electronics, 15, okay. Analog and digital, almost this time 11, last time 10. Signal processing, same, 14 marks. Control system, 13, okay. Electrical machines, 14, last year it was 13. Power systems, 13. And power electronics and drives together it is 11. So relatively you see, after the change in syllabus and pattern in 2017 for ESE, the weightage is uniformly distributed. There were days before that unequal distribution, paper 1, paper 2, you know what would have happened. Now this is a very uniform distribution. So altogether this is the subject weightage, but as a student to crack, you need to know basics of all subjects. But even in each subject, there are some questions that you should not attempt. There are some questions which are deep in mathematics where no one can solve in 1 minute. So that selectivity is important. So which to eliminate, which to consider, and if you attempt, how to attempt in 1 minute. Now our faculty team will solve these solutions in 1 minute and less than 1 minute. Okay, how to eliminate, how to guess the nearest answer. Okay, now I would welcome our faculty team. We will start with control system, Gnaneshwar sir.
Hello. Now, good evening, dear students. Now, from control system, we got 13 questions. Okay, 13 questions. First question, we'll observe. Control system. Which error time graph is relevant to the following integral mode control output? Examiner was given output. Now, what could be the input? So, here options are given. What are the options are given? Once observe the options here. Now, I'm writing the options here. So, if you integrate what option, you will get the correct answer. Now, option A is given, yes, this one. Option A is given. Now, yes. Dear students, if you integrate this one, will you get this type of output? No, it's wrong answer. It's the wrong answer. Option A is wrong answer. Now, if you go for the option B here, so we'll go for option B, option C, option D. Now, I'll write all at the same place. Option D. Now, dear students, here observe. Yes, what is the option B is given? This option B is given. This option C is given. This option D is given. Now, here, if you integrate this one, 3 may be possible, but your given option is, it is reaching to the up to infinity. It is reaching up to infinity. But if you do the integration, what happens now? This answer could be like this. This answer could be here. Now, like this. So option B, option D, if you integrate this one, will get. Now, if you do the option B, we'll get the like this. So option D is wrong. Like option C also wrong. Why? Because limited values. It is reaching to up to infinity. Hence, option B is possible option. Option B is correct option here. Now, once again, I am writing. It is up to infinity. These two are finite, but it is given infinity. So, best suitable option is option B is correct answer. First question, option B is right answer here. Now, simple logic. This one, input. For what if you do the integration, you will get this answer. Do the integration for the option. This integration never be. This ramp integration could be, ramp integration is parabolic. So the answer is not parabolic here in the question paper. Obviously these three are, it is a limited, but it is a infinitive. Obviously it is also infinity. So option B is correct answer. Next we'll go for the one more question. Yes, very simple question. Phase angle of this question. Now, dear students, phase angle of 1 plus st, 1 plus k upon 1 plus st, numerator 0, k constant, denominator minus, tan inverse of s equal to omega t by 1. Obviously, option A is correct answer. 47, option A, direct, without touching pen to paper, with eyes only we can tell the answer, 47. By seeing the question paper only we can tell the answer. Now, similarly, 48 here. Which of the following steps are correct while plotting the open loop Bode plot? Transfer function into frequency form. No, it should be time constant form. While writing the Bode plot, transfer function should be in the time constant form. For the low frequency asymptote, if there is only one proportional link constant, there should be a plot horizontal line with the amplitude value. So what is the option B is telling that if k constant is present, what is the line will get? Plus 20 log k. Gain always present in the numerator. Gain always present in the numerator. So it should be plus 20, but it's given minus. So option B also wrong. Option A also wrong. Compensate the asymptote to get the precise constant time characteristic form irrelevant. So obviously for frequency asymptote, one should change the slope of the asymptote in every break point. So what is the options is telling? At every corner frequency, there should be change in the slope. Obviously, it is the correct answer. Okay. Every corner frequency, there should be slope change. So your suitable option is option C. Okay. We'll go for the one more question. Here, observe. For the closed loop transfer function as a part of necessary condition, stability, no conjugate pure complex roots. Pure complex roots here. Pure complex roots means, let us, example I am taking option B, second statement. Let us I am taking 2 plus 3j. Know this part. Know this part means, it could be, know this part means what? No complex conjugate roots. So, maybe real, maybe imaginary, pure, okay, imaginary. If the poles are in imaginary, system should be marginal stable. If the poles exist on imaginary, system possibility for marginal stable as well as there is chance of unstable also. Repeated poles on imaginary, there is chance of unstable also. But examiner is asking only condition for stability. Condition for stability, so obviously this should be eliminated. This should be eliminated. Why? Because real and imaginary. No complex conjugate means this is this format. No. No means other possibility. We have the three types of roots are possible. One real, one imaginary, third one is complex conjugate. So clearly saying that no complex conjugate, there is a possibility, remove this one. So after removing second option, yes, all the roots must be negative. Yes, for stability, all poles should be negative side. So obviously best suitable answer is 1 and 3. 1 and 3 is option C is correct answer. Yes. Okay, we'll move to the one more question. Here, this is a controversial question. There are two possible options here. Examiner is asking condition for stability. Just to verify. stability in the RH method, Routh array table, all the first column should have the same sign, first thing. So first one is given, positive is given. First one is given positive means these two should be positive. Positive means substitute positive, all are possible options here, okay? If you substitute the 15, 4 into 15, 60, 32 minus 60, negative, sign change. So 15 is wrong answer, okay? Substitute 12 here, option C, 4 into 12, 48, 32 minus 48, there is a negative symbol, so option C also wrong. Now substitute option B here, 6, 4 into 6, how much? 24. 32 minus 24, yes, positive. 6 is possibility, option B and D. And not only this one, stability condition, examiner is asking instability condition. For what values of K, system becomes unstable. So now, two options are eliminated. There are two in the race. Now, tell me, option B I am writing, 12. 4 into 12, negative sign. 32 minus 48, negative sign. But here option D also, 4 into 15, 60. So dear friends, here both are suitable options. So option B and option D are correct answer here. Option B and option D. Maybe I think here one is okay, but here given data, option B and option D both are suitable. Now we'll move to the one more question. Yes, this is a, we'll discuss regularly in the class. Directly table is given. Directly table is given. Here observe. Now, yes, step input. For step input, here for step input, what is the possibility? For type 0 system, it should be constant. For step input, type 0 input constant, type 1 0, type 2 also 0, type 2 also 0. So is given, fill in the blanks, A, B, C. So obviously C value should be 0. C value should be means is asking A, B and C respectively. First we got C value. So last one should be 0, 0. So C and D options are eliminated, A and B are, okay, there is a possibility. Next to RAM signal observe. RAM signal means infinity. Second one should be constant here, constant. Option B is constant. Okay, B is constant, 0. But A and B both are constant only, middle values are both are constant. Ramp input, the steady state error equal to what? Steady state error for ramp input, 1 by kV format only, 1 by kV format. For step input, 1 by 1 plus kp, this is for step input, this is for ramp input. Option B is given for step input, wrong. So your best suitable option is option A is correct answer here. Option A is the correct answer. Okay, we'll move to one more question. Which of the following is not a method? Here examiner is given not a method to reduce the steady state error of a system. Increase the loop gain, correct answer. Limiting system types. We can reduce the steady state error by increasing the type of the system. Here steady state error is inversely proportional to the type, okay. By increasing the type of the system, we can reduce the SSC. But examiner was given limiting, controlling. No, it's not possible. This is not a correct method. It is not a correct method. Option B is correct answer. Same, if we move to the one more question. Consider the following statement related to the root locus. Root locus. The number of branches of the root locus equal to the number of open loop poles generally, but open loop poles equal to closed loop poles. So first one is correct one. First one is correct one. Root locus symmetrical about real axis, 100% correct. With respect to symmetrical, correct answer. Root locus approaches straight line as asymptote approach to infinity. Yes, at infinity both are straight line only. 3 is also correct. So best suitable answer is option D is perfect answer. Now we'll move to the one more question. It is a very basic question. Lead compensator here. I think explanation also not required. Lead compensator. For lead compensator here, what is a lead compensator? Now, first 0, then pole here. 0, constant, the frequency variation, gain. So first one should be constant, next 0. 0 means plus 20, Bode plot, plus 20. Then again pole, minus 20, plus 20, minus 20, 0. So obviously this is the lead compensator frequency response. So this is a 54. 54B is correct answer. B1. Here also B, option also B only. Now we'll move to the one more question. The root locus path of a root's characteristic equation traced out in the explain as a system parameter variation 0 to infinity. Correct answer. First one is correct. First one is 100% correct. Statement, the root locus is the definition, basic definition of the root locus. Directly here examiner was given definition of the root locus. Now, the frequency response of a system is defined as a steady state response of a system non-sinusoidal input to the signal and resulting output signal for a linear system is sinusoidal. Wrong dear. Steady state response here. If you apply the sine input, the output should also sine. Sinusoidal input. So the answer should be here non-sinusoidal word is given. If the question is sinusoidal input is given, then second statement also correct. But because of non-sinusoidal input, statement is wrong answer. Statement is wrong answer. So only statement 1 correct answer. So here suitable option is option C is perfect answer. Now we'll move to the one more question here. A negative feedback system has a forward path gain of 18. Forward path gain of 80 and feedback path gain of 0.5. What is the overall gain? Very basic question. This question was given. So overall gain equal to what dear? Come on. I think for IES people this is a very simple question. G is given 18. H is given how much dear? 0.15. So overall gain here. Overall gain equal to the formula G upon 1 plus GH here. Substitute this one. If you calculate, simple you will get 4.86 dear. Very simple question. Now option A is a perfect answer here. Option A is perfect answer. Next. Yes. Consider the following statements. Condition for second order system when subjected to unit step input. With critical damp, there are no oscillations. 100%. Okay. Critical damp, there is no oscillation. First statement is correct. Now, with no damping, zeta is 0, the system output oscillate with constant frequency and variable amplitude. No, wrong. Variable amplitude, okay, wrong dear. This is a constant, now amplitude, constant amplitude. This is the correct answer for this option, okay, second statement. So obviously second statement is wrong. First statement is correct. With over damping, the output takes longer time to reach the steady state output. Correct only. As compared to this one, correct only. Steady state. Third statement is correct. So 1 and 3 is correct answer. 1 and 3. Option D is perfect answer, dear. Option D is perfect answer. Okay, this is a. Now, in Nyquist stability criteria, direct definition was given. Definition here, Nyquist stability criteria, variation frequency 0 to infinity, do not encircle the minus point. Okay, minus 1 plus J0 point. Minus 1 means minus 1 plus J0 point should be outside here. If it is outside, it is not enclosing. Not enclosing means it is a stable condition here. It is a condition for stability. It is condition for stability. Yes. Now option D is perfect answer. Yes, option D is perfect answer. Now dear students, these are the questions from the control system. Now I welcome next faculty. Now continue by signals and system. Slider. Okay students, from signals and systems subject, total 14 questions have asked. The first question is, a continuous time signal is given below, x of t equals to 8 cos 2000 pi t. What is the minimum sampling rate required to avoid aliasing? It is a standard question. So what is the minimum sampling rate required to avoid aliasing? 2 FM, where FM is the maximum frequency of the signal. So what is the frequency given? Omega m is 200 pi. From this, FM is how much? 100 hertz. So 2 FM becomes how much? It is 200 hertz. So what is the right option from this? 200 hertz, and the right option is B is the right option. Next, how many number of multiplications is needed in the calculation of FFT with a 64-point sequence. So how many number of complex multiplications are needed? N by 2 log n base 2. N is given as 64. So 64 by 2 log of 64 base 2. 64 by 2 into log 64 base 2 is how much? 6. 2 1 ja, 2 3 ja. 64 into 3, this is equals to 192. So what is the right option? C is the right option, 192. Okay? Yes. And the next one. Which of the following is the correct Butterworth polynomial for second order filter? It is a standard one. For second order filter, what is the standard Butterworth polynomial? S square plus root 2s plus 1. Okay, we have provided table in our material and also we are teaching this in our class also. Okay, yes. And the next one. Which of the following is the correct relationship mapping from the S plane to the Z plane in bilinear transformation? This is also no need to solve anything. The relationship is S equals to 2 by T into 1 minus Z inverse by 1 plus Z inverse. So what is the right option? D is the right option. Next, the fundamental period of complex signal x of t equals to e power j omega naught t. So what is the fundamental time period? T naught is equals to 2 pi divided by omega naught. What is the omega naught? Fundamental angular frequency of the signal? Yes. How much is the fundamental angular frequency given? Omega naught itself. So 2 pi by omega naught. So what is the right option? A is the right option. Next one. The energy contained in the signal x of t equals to e power minus 2t into u of t is how much? What is the energy formula? Energy of x of t equals to limit t tending to infinity 1 by 2t minus t to t mod x of t whole square dt. And the given signal is limit t tending to infinity 1 by 2t integration 0 to t e to the power of minus 4t dt. Just to solve this integral, you will get the answer as 1 by 4. Okay? Yes, the answer is 1 by 4. Which of the following is a useful property of unit impulse signal? Yes. See here, del of at equals to a into del of t, wrong one. Del of at equals to del of t, this is also wrong one. Del of at equals to del of t whole power minus a, this is also wrong one. Del of at equals to 1 by modulus of a del of t, yes, this is correct one. Okay? Yes. And the remaining questions will be solved by Narsimham sir.
No? Thank you, Srikanth sir. Let us see the other models. Yeah. Which one of the following is correct for system represented by the relation? This is a standard model which we used to solve in the class. Very funny model. He asked about linearity and causality. Of course, it can be linear. That will obey superposition principle. But it cannot be causal. If you are choosing the output at minus pi, a specific instant, it is expecting the input at 0. Present output asking for future input. So the correct option is what? Linear and non-causal. Linear and non-causal. Let us see the next model. Funda. Fourier series representation of a signal is based on what? Orthogonality principle standard. First point which we learn in the chapter is this only. What is orthogonality? Area under product of two signals must be 0. Standard orthogonal signals like sinusoids, both sine and cos, complex sinusoids, e power plus or minus. So it is asked the Fourier series representation is based on what? Orthogonal functions. Standard question. Okay. This is also standard. Rectangle, we are expecting Fourier transform. Direct answer is what? Area 2k T naught, SA of omega into positive width of the rectangle T naught, positive width. Because it is expected in simple, sinc x is sin pi x by by x. If you are habituated to SAP function style, convert to sinc. Sinc of omega t naught by pi. You can feel which option? Option A. Straightforward question. Let us see the next model. E power minus mod t two-side exponential. Standard answer 2 by omega square plus 1 txt j into d by d omega of original spectrum frequency differentiation property. Try to differentiate it. You can see the rest of the enjoyment. Simply differentiate it. Minus 4j omega by 1 plus omega square whole square. Funny thing is, last year GATE, this is EC question, this year copied for you. Electrical ESE paper. Okay, very simple. Application of frequency differentiation property or not. Such an easy model. I feel options may be wrong here. Xt is a periodic signal with a time period for 2 pi by t naught means pi by 2, sir. Xt is real valued function means cos or sine. According to the options, we can feel like that. Ck is 0 for mod k greater than 1. Chance of DC and first harmonic. But he stated he considered a new signal yt, dk is e power minus j pi k by 2 into ck, time shifting property. X of t minus t naught is e power minus jk omega naught t naught into original coefficient ck. He stated yt is odd. Yt is odd. Odd means maybe DC 0, maybe. Because the options are not clear. Okay. Last one is Parseval's theorem. Power in the signal is 1 by 2. But which harmonics are present? Normal power relation is sigma mod Cn square. Chance for only first harmonic means mod C minus 1 square, C1 square. Generally magnitude spectrum is even symmetric. There is a chance that C minus 1 and C1 will be 1 by 2. 1 by 4 plus 1 by 4. Okay. So now you can write very easily xt because of our standard relation sigma Cn e power j omega naught t. So 1 by 2 e power j 1 into pi by 2 into t 1 by 2 e power j minus 1 into pi by 2 into, that will appear like which function? Cos pi t by 2, that is cos omega naught t form. Maybe options are incorrect. Maybe. Okay, very simple. Real valued mentioned, power mentioned. From the third point we got the clarity, chance of DC and first harmonic, maybe DC 0 because of the fourth point, Parseval's theorem. Okay. This is a lovely question which is asked from digital signal processing by ProACIS, standard problem. Generally, you can deal the transfer function like B naught by 1 plus A in Z inverse plus A to Z power minus 2. That is a second order transfer function. Maybe that fellow has mentioned like alpha 1, alpha 2, sir, for us. Alpha 1, alpha 2. Normally when you solve the poles location, for stability, because it is already causal, magnitude of pole must be less than 1 or not? Magnitude of poles must be less than 1. When you solve for the poles, minus b plus or minus root of b square minus 4ac by 2a, these are the poles location. But as we are expecting the condition on alpha 1, alpha 2, the roots of the characteristic equation reverse way if you solve. If you solve reverse way, alpha 1 is minus p1 plus p2, alpha 2 is p1, p2 you will get. Okay. So based on that, after simplification, you can feel that like option B, mod alpha 2 less than 1, mod alpha 1 less than 1 plus alpha 2. This is the only good question you can feel in the exam this year. So next, these are some models we got in signals. Next, Professor Satyanarayana sir will come to deal analog topic.
Hello. Bರ್ತದ? Right. Myself is Satyanarayana. So we have to analog electronics. Coming to the first question, diodes designed expressly to operate in the forward bias region are called Zener diodes. So Zener diode is operating in the reverse bias region. So the option, this statement 1 is wrong only. The principle of operating region for a Zener diode is negative in terms of both voltage and current. So Zener is operated always in the reverse bias region only. So that statement 2 is correct, statement 1 is wrong. So your answer is D. Statement 1 is wrong, statement 2 is correct only. Coming to the next question, the small signal equivalent of a BJT that applies to both PNP and NPN transistors is valid at low frequency by ignoring the capacitance effects. So generally, the capacitance effect means transistor capacitance effects. So that is neglected at low frequency, so that whatever the equivalent circuits we have discussed, that are for low frequency only. So statement 1 is correct. Second statement is, despite the structural similarities, a PNP transistor has higher current gain than comparable to PNP, NPN BJT, because holes are less mobile than electrons. So mobility of electrons is more than the mobility of holes, but as electron mobility is more, the conductivity in that one more, so you will get higher current gain for NPN only, not for PNP. So statement 2 is wrong. So statement 1 is correct, statement 2 is wrong. So your option is C only. Coming to the next question, MOSFETs are preferred over JFETs for digital integrated circuits, either P-channel MOS or N-channel MOS. Logic circuits can be constructed. So MOSFETs are preferred over JFETs. So this statement 1 is correct. The usage of P-channel MOSFET as active load for N-channel MOSFET leads to logic family, which is called CMOS. In the CMOS, P MOSFET is load only. So that this is also correct only. So both the statements are correct, but the statement 2, these two are not correct explanation of your statement 1. So your option B. Both statements are correct, but not correct explanation. So coming to the next question, consider the following statements regarding biasing of PN junction. The depletion layer width gets narrowed down on application of forward bias voltage. As forward bias voltage increases, your depletion region width, depletion region decreases. So depletion region width gets narrowed down, decreases. So this is correct statement only. Forward biased PN junction offers very high resistance. The forward bias junction always offers the low resistance, so that statement 2 is wrong. The barrier potential increases when junction reverse bias voltage increases. Whenever the barrier potential increases, so the depletion region width increases, so its potential also increases. So 3 is correct. The majority charge carriers current is established in the forward bias PN junction diode. So whenever the junction is forward bias, current due to majority carriers, when current due to minority carriers in the reverse bias only, so statement 4 is correct. So in the given 4 statements, 1, 3, 4 are correct. So your option is C. Coming to the next question, which of the following is the correct representation of Boltzmann diode current equation with standard notations, where I is the diode current, where V is the bias voltage, and Vt is the thermal voltage. So your diode current equation is direct question, I naught into e power Vd by neta Vt minus 1. So option A is the correct one. So coming to the next question, the common emitter configuration is widely used due to its, for CE, voltage gain is very high, power gain is what? Voltage gain into current gain. Voltage gain into current gain. As the voltage gain is very high, your power gain also becomes very high only. Because AV AI is beta only. So this is very high. So high voltage and high power gains, option C is the correct one. Coming to the next question. A silicon diode made half-wave rectifier produces maximum value of load current as 20 milliamperes through a resistance of 1 kilo ohm. What is the PIV voltage of the diode? So whenever the diode is reverse bias, this is voltage across the diode and load current. But what is the load current is given? Load current is 20 milli and the voltage across this is 20 volts. Now this requires 0.7 volts. Na? So total voltage required is 20.7 is the peak inverse voltage of the diode used in the circuit. So total 20 volts across the load and 0.7 volts required for that. So total of 20.7. So option D is the correct one. Coming to the next question. Ripple factor for a half-wave rectifier and full-wave rectifier are direct question. So the ripple factor of half-wave rectifier is, it is 1.21, whereas the ripple factor of full-wave rectifier is 0.483. So 1.21 and 0.48. Option C is the correct one. Next question. If a transistor has the value of common base current gain is alpha, it is 0.98. What is the value of common emitter current gain? Beta is how much? So beta is how much? Alpha by 1 minus alpha. So it is 0.98 by 1 minus 0.98. So you will get 49. So option B is the correct one. Coming to the next question. A junction FET is a 3-terminal. JFET is voltage controlled current source. So voltage controlled current device. Coming to the next one. Consider the basic MOSFET circuit shown in the figure with variable gate voltage. The MOSFET is given to have very large value of VA. That is, VA is, you can say, early voltage. VT is 4 volts, IDSS is 8 milliamperes. What is the value of ID for VGS is equal to 4 volts. Given FET is E MOSFET. This is E MOSFET, enhancement MOSFET. As it is enhancement MOSFET, now what is the value of ID for VGS is equal to 5 volts. VGS is given 5 volts, threshold voltage is given 4 volts. Then what is the value of ID? Generally, the value of ID of this is K into VGS minus VT whole square, where K is your ID maximum by VGS minus VT whole square. Now what is the maximum value of ID? So as you are taken, for maximum value of that, VDS you take 0. So then ID maximum you will get 20 volts by 5 kilo. That is 4 milliamperes of maximum current passing through the device. So 4 into 10 power minus 3 by VGS is 5, VT is 4. So this you will get 4 milliamperes per volt square. So that is the value of K. Once you will get that value of K, ID is 4 into 10 power minus 3 into 5 minus 4 whole square. So this is 4 milliamperes. But unfortunately, there is no option in that one. So this 4 milliamperes current passing through the device. Coming to the next question. Which of the following is the correct circuit symbol representation of P channel? For P channel, these two are MOSFETs, these two are JFETs. At the gate arrow is into is there, which is N channel. If the arrow is out is there, it is P channel. So the option B is the correct one. Coming to the next question. Consider the following statements regarding FET amplifier configurations. Common source and common drain configuration in this, that is R1 R2 parallel combination, can be neglected to be selected to be large during the bias design. As that is selected large, the current passing through that is very low only. So this is statement 1 is correct only. For the common drain configuration, the voltage gain, common drain is nothing but voltage follower only. So voltage gain is generally less than unity or near about unity. Statement 2 is correct. For the common gate configuration, the current gain cannot be larger than unity. Common gate is current buffer. So whose current gain is unity only, cannot be greater than unity. So statement 3 also correct. So your option D is the correct one. Which of the above statements is or are correct? So 1, 2, 3 are correct. So option D is correct one. So next question is, an amplifier has bandwidth of 500 kilohertz and voltage gain of 100. What amount of negative feedback if bandwidth extended to 5 mega? For any system, gain bandwidth product is constant. Gain into bandwidth is constant. Means with feedback or with cascade also. Now your gain into bandwidth, this is without feedback, is equal to gain into bandwidth with feedback. Now the gain of your without feedback is given 100. Bandwidth is how much is given? 500 kilo. So 500 into 10 power 3 is equal to gain of the amplifier is, let's consider AF, and bandwidth is extended to 5 mega, 5 into 10 power 6. Now the value of AF is 50 into 10 power 6 by 5 into 10 power 6. So we will get 10. As AF is 10, what is the value of beta? So AF is equal to A by 1 plus beta A. Now the 1 plus beta A is A by AF, which is 100 by 10, you will get 10. So beta A is 9. So beta value is 9 by 100, so 0.09. So option C will be the correct one. Coming to the next question. An amplifier has an open loop voltage gain of 1000. Open loop voltage gain is 1000 is given. If 10% negative means beta is 10% is given, which is nothing but 0.1. Voltage series feedback is used. What is the closed loop gain? The closed loop gain of any system is A by 1 plus beta. Now A is 1000 by 1 plus 0.1 into 1000. So we will get 1000 by 101. 1000 by 101 is 9.9 approximately. So option C will be the correct one.
Hi, I am Dr. A.V.S. Prasad. I am going to solve engineering mathematics questions. Let's see the first question. The general solution of the system, this is homogeneous system in 5 variables and 3 equations are given. Okay, here 5 variables are there, x1 to x5, but 3 equations are given. We know that if number of equations is less than number of unknowns, there will be infinitely many solutions. So no doubt 2 variables are to be parameters. So the 2 variables you can take x4 as alpha and x5 as beta. Okay, so the solution would be capital X equal to alpha into something, means here 1 0 will get plus beta into 2 parameters. So here 1 0. Okay, this would be the correct answer. So let us see the options. So which option? Option A is the correct answer. Am I right? Right. Let's see the next question. If the eigenvalues of the matrix A equal to 5 minus 2, m minus 6 or 3 minus 4, then what is the value of m? We know that determinant of a matrix equal to product of the eigenvalues only. Product of eigenvalues. So what is the determinant here? Minus 30 plus 2m only. Equal to eigenvalues are what? 3 and 4. So 3 into minus 4 only. So therefore 2m equal to, this is minus 12 and minus 30. So this is equal to 18 only. So m equal to 9 only. So which option? Option D is the correct answer. Am I right? Let's see the next question. If z equal to f of x plus ct plus pi of x minus ct, then z square dou square z by dou t square equal to what? So this is directly, we know that solution of one-dimensional wave equation. Wave equation is what? Right? What is the wave equation? We know that dou square z by dou t square equal to c square into dou square z by dou x square only. Means what? Which option? So option B is the correct answer. This is the solution of the standard formula, standard form, direct formula. So solution of one-dimensional wave equation is this one, that is option B is the correct answer. Let's see the next question. The volume of the solid enclosed between the paraboloids z equal to 5x square plus 5y square and z equal to 6 minus 7x square minus y square is what? Right. So let it be equation 1 and let it be equation 2. Okay. So by solving these two, so 5x square plus 5y square equal to 6 minus 7x square minus y square only. So by simplifying we will get, look at here. So this is going to be 5x square plus 5y square and z equal to 6 minus 7x square minus y square only. So by simplifying we get 12x square and this is 5 plus 7, 12x square, and this is what? 6y square equal to 6 only. Means what? 2x square plus y square equal to 1 only. So volume of the enclosed between the two paraboloids. So therefore volume formula equal to triple integral of, right? This is going to be dx, dy, dz only. So the limits are what? Here z limits are what? Or dz we can write dz, dx, dy also, anyone, right? So look at dz, dx, dy. Either dz, dx, dy or 1 minute. So we can write here, right. So dz, dy, dx. So the limits are going to be what? Integral of, right. Here z limits are what? 6 minus 7x square minus y square to 5x square plus 5y square, z limits. Y limits are what? From this one y limits are what? Y equal to minus root over 1 minus 2x square to root over 1 minus 2x square. And what about x limits? 2x square equal to 1. So x equal to what? X limits are going to be what? X equal to, right, 2x square equal to 1, x equal to minus 1 by root over 2 to 1 by root over 2 only. Because y equal to 0 means 2x square equal to 1, x square equal to 1 by 2. So x equal to plus or minus 1 by root. So here dz, dy, dx only. So you can simplify. By simplifying you will get the value as 3 pi by root over 2 only. So option B is the correct answer. Am I right? So let's see the next one. The Fourier series representation of f of x equal to x, 0 less than equal to x less than equal to pi, and pi from pi less than equal to x less than 2 pi is what? Right. So we have to compute an value, constant term a naught, an and bn, right? So we'll upload the detailed solution soon in the website. So option A is going to be correct answer. Let us see the next question. The value of complex integral, right? Integral over e power 1 by z dz, where the gamma is what? Closed path enclosing the origin is what? So what is the formula? This is going, we know that integral over c f of z dz equal to what? 2 pi I times residue only, sum of the residues only. Yes, correct or not? So we have to calculate the residue. Here what is the singular point? Very clearly f of z is what? E power 1 by z only. So z equal to 0 is the singular point. Okay, is the singular point. So at this point we have to calculate the residue. How do we calculate? Right, simple. We know the expansion e power 1 by z expansion is what? Expansion of e power 1 by z is what? 1 plus 1 by z plus 1 by 2 factor, right, 1 by, 1 minute. So this is going to be 1 by 2 factorial into 1 by z whole square plus etc. so on so on. We know that the coefficient residue is what? Residue equal to what? B1 equal to coefficient of 1 by z only is what? Coefficient of 1 by z is what? 1 only. Am I correct or not? Therefore answer is what finally? Therefore the value, required value is what? 2 pi I into only one residue is there, 1. So answer is 2 pi I only. So which option? Option B is the correct answer. If let f of z equal 2iz plus 6z bar, then the value of f at z equal 1 by 2 plus 4i is what? Right. Given that z equal 1 by 2 plus 4i, so z bar is very clear, conjugate is what? 1 by 2 minus 4i only. What is the required value? F of z equal to 2i into z. Z means what? 1 by 2 plus 4i plus 6z bar. 6z bar means what? 1 by 2 minus 4i only. So first write the real part. Look at here, 6 by 2 means 3. Here 2i, 2i. 2i into 4i. 4i means what? 8i square. 8i square means what? Minus 8 only. Minus 8 plus 3. That is what? Minus 5 only. So real part is minus 5. So option A and B are eliminated because the real part is plus 5. So either C or D. Next, imaginary part. Imaginary part is what? Here I, and here is what? Minus 24i. Minus 24i, I. That is minus 23i only. So which option? Option C is the correct answer. Right? Option C is the correct answer. Let's see the next question. What is the root of the equation x sin x plus cos x equal 0 up to the 4 decimal places? So detailed solution will be uploaded soon in our website. So this equation will cut x-axis at x equal to 2.7984 only. So option D is going to be correct answer. Right. Which are the following general integral of the linear partial differential equation y plus xz into p minus x plus yz into q equal x square minus y square? We know that this is Lagrange's PDE only. Yes, correct or not? How do we evaluate this one? By writing the subsidiary equations. What are the subsidiary equations? Look at. So dx by. So we write dx by, what is the standard form in fact? Capital P into small p plus capital Q into small q equal to r only. So what are the equation? Dx by capital P equal to dy by capital Q equal to dz by r only. So what is p here? So dx by y plus xz. Here dy by minus x minus yz only equal to dz by x square minus y square only. So we have to choose the multipliers. What multipliers? L into x y plus xz plus m into minus x minus yz plus n into x square minus y square equal to 0. We have to choose the multipliers L, m, n twice, 2 times independent multipliers. So by taking here L equal to, look at, by taking L equal to for what values? Look at, suppose by taking L equal to Y and M equal to X and Z equal to 1, satisfies or not? Look at, so a Y into Y, a Y square, minus Y square get cancelled. Next, Y into XYZ, here minus XY cancelled. Next, minus, so you clearly satisfying. Therefore, the solution is going to be what? So integral of L dx plus M dy plus N dz equal to C1 is the one solution, right? So what is L here? So integral of L means what? Y dx. M means what here? X dy. Z means, N means what? 1 into dz equal to C1 only, right? This is one solution. Very clearly this is going to be, look at here, right? Therefore, y dx plus x dy, am I correct or not? Y dx plus x dy, right? Integral of plus integral of dz equal to constant C1 only. So this is nothing but derivative of xy only, integral of plus integral of dz equal to C1 only. That is what xy plus z equal to C1 is one solution. So we need the general solution. Similarly, again by choosing L, M and multiplies, sorry here not M here, 1 minute, this is N equal to 1 only, L, M, N multiplies. So by choosing again L, M, N, we get one more solution. So the general solution will be one of the options. Look at here, which option containing the solution xy plus z? Look at option A only containing xy plus z, so A is the correct answer. So the second solution would be x square plus y square minus z square only, right? So the solution is obtained by method of multipliers. Look at, suppose that random variable x has the distribution function f of x equal to 0 and for x less than or equal to 0, 1 minus e raised to minus x square for x greater than 0. What is the probability that x exceeds 1? So you are required to calculate probability of x greater than 1, right? X exceeds 1. X greater than 1 means what? Integral 1 to infinity f of x into dx only. So integral 1 to infinity, right, we have to simplify 1 minus e power minus x square into dx only, right, into dx only. So this is going to be, look at, so x greater than 1 equal to, this is a probability of x greater than 1. So this is going to be, okay, here given that capital F of x is given, so we want the small f of x. Small f of x is what? Derivative of capital F of x only. So this is going to be what? 0 for x less than or equal to 0, and for x greater than 0, this is going to be 1 derivative 0 minus e power minus x square derivative is what? E power minus x square into minus x square derivative minus 2x, so 2x into e power minus x square. This is for x greater than 0. So this is going to be, look at, right. So this is going to be 1 to infinity, 1 to infinity, right. So 2x into e power minus x square into dx only. This is capital F of x. Small f of x equal to derivative of the capital F of x only, right. So therefore, by substituting, put x square equal to t. So simplify this value. So 2x dx equal to dt only. So this is going to be integral 1 to infinity, 2x dx means dt only, e power minus x square means e power minus t only. By simplifying, the value is going to be 1 by e only. So which option? Option B is the correct answer. Next, a total of 28% of American males smoke cigarettes and 7% smoke cigars and 5% both, then what percentage of male smokes neither cigars nor cigarettes? So we can use simple Venn diagrams. So this is cigarette suppose and cigar, right. So this is 28% and this is 7% and common 5%. What is the probability of neither nor? So probability of neither nor equal to 1 minus probability of either or. Either or means what? 1 minus probability of A or B, that is 1 minus probability of 28 by 100 plus 7 by 100 minus 5 by 100, like probability of A union B. So probability of A plus probability of B minus probability of A and C. 28 plus 7, 35 minus 5, 30, 30 by 100. So 1 minus 30 by 100. So this is going to be 70 by 100 only. So which option? 70%, option D is the correct answer. Right. If the average number of claims handled daily by an insurance company is 5, what proportion of days have less than 3 claims? Assume that the number of claims on different days is independent. So what distribution? Poisson distribution. So here given that lambda equal to 5 only, parameter of the Poisson distribution. What is the required value? 3, right? Insurance company is 5. What proportion of days have less than 3 claims? So probability of x less than 3 is required. Probability of x less than 3 is required. So probability of x less than 3 equal to what? Probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 only. This is to be simplified. So E is what? E power minus lambda into lambda power 0 by 0 factorial plus e power minus lambda into lambda power 1 by 1 factorial plus e power minus lambda into lambda square. Lambda square means what? 1 minute, right? So here this is going to be lambda square only. So lambda square by 2 factorial. So e power minus lambda common. Lambda is what here? 5. E power minus 5 common. So here 1 only, here 5 only. This is what? 5 square means 25 by 2 only. So this is what? 6. 6 2s are 12. 12 plus 25, 37. So 37 into e power minus 5 by 2 is the correct answer. So which option? Option A is the correct answer. So next faculty will continue the session.
But not on 8085 microprocessor, but 8086 microprocessor, right? The question on instruction side, programming side. Let me read the question for you. According to the description of the AND instruction of 8086 microprocessor, what are the essential conditions to be satisfied while executing it? It is about AND instruction, logical instruction of 8086 microprocessor. What are the essential conditions to be satisfied while executing it? 4 statements are given. You are supposed to identify which one of the statements is true, either maybe one or more than one statement. So before going through these statements now, let's
which are said to be essential conditions to be satisfied. Let me give you the instruction syntax, END and instruction, destination comma source. That is the exact syntax for 80869. Okay, so let me provide the solution for this question. It is about AND instruction, as I mentioned already. Let me just give the first syntax of this 8086 instruction, please. A and D, destination, comma source. That is the syntax, please. Okay. So what is the operation? It is not ANA. This is not 8085 microprocessor. Not neither ANA nor ANI. It is AND and instruction. So what is the operation for this instruction, please? Whatever be the source operand, right, will be ANDed with the destination operand, right, and the result is said to be stored back into destination operand. That is the operation. But there are some conditions, just like that any operand can be given here. Conditions are, the source operand can be a register, it can be a memory location, it can be an immediate number given in the instruction. Again, I am repeating, source operand can be a register, can be a memory location, or can be a immediate given number in the instruction itself. Whereas the destination operand can be a register, it can be a memory location, but it cannot be an immediate number. If you give simple logic, if you give immediate number here, result cannot be stored into that immediate number. Those are the conditions, please. And another point is, both the operands cannot be memory locations. Both the operands cannot be immediate numbers. One of the operands, at least one of the operands should be a register or memory location. Right? I will just give some examples, then we will go back. One example, something like say, and AL comma BL. That is perfect. I am not writing the operation, you can understand. BL register, which is 8-bit register, is ANDed with the contents of AL register. Result will be stored back into AL register. But you cannot give, I am writing here, and AL comma BX here, because BX is a 16-bit register. This is wrong. BX is a 16-bit register. I am not going to AND it with a 8-bit register. Right? That is one thing. Another example I am giving here. And AL comma something like say memory location 8000 hexa. So what happens here? The value inside the memory location address 8000 hexa will be ANDed with the AL content. Result will be stored back into it. Right? One more example I am giving. And AL comma, instead of putting it in brackets, no, if you give 80 hexa, that will be treated as an immediate number. The number given, immediate number, immediately available to the CPU, 80 hexa, will be ANDed with the value inside AL. The result will be stored back into AL. But you cannot give this 80 hexa as a destination. That is meaningless, please. Reason, because reason is result cannot be stored into 80 hexa. 80 hexa is an immediate number given in the instruction. So one more possible example I am giving here, and something like say this 8000 hexa, that is a memory location, comma AL. Just I am writing AL, instead of AL you can also give BL, AL. So you see, whatever be the value inside AL register will be ANDed with memory location. Result will be stored back into same memory location. But my point is, you cannot give both memory locations. Please understand, 8000 hexa comma 9000 hexa. This is not possible. This is not allowed. Both cannot be memory locations. And one more example I am giving here, and 80 hexa comma 90 hexa. This is also not possible. You cannot add two numbers. You cannot give destination operand as a number, right? So these are the conditions. Let's see now options given. The source can be a register or a memory location. Yes. If you want me to add another point here, I will say or can be immediate number. The destination can be a register or a memory location. Correct. It cannot be an immediate number. The source and the destination must both be bytes or be words. Both should be lengthwise matching, right? Source operand and destination operand. That is also correct. Source and the destination cannot be both memory locations in an instruction. That's what I mentioned here. Both cannot be memory locations, both cannot be immediate numbers. So I will go for which option? 1, 2, 3, 4. All the 4 options are correct here. So solution is C. C is the answer, right? So the next faculty will continue. Forward to next faculty.
Hello. Hello. So my dear friends, now we are going to discuss the questions related to subject power electronics and machine drives. Altogether 11 questions they asked and the questions level is around easy to moderate. Okay, let us discuss one by one. So very first question, by considering the standard notations, reverse recovery time TRR of a power diode is. Very straightforward question. We have already discussed and we have derived the expression also. Okay, reverse recovery time TRR is equal to under root 2QRR, or you can say it is 2QR upon di by dt, where QR is nothing but reverse recovery charge. Alright, so option A is the correct option. Second, the overdrive factor of a power transistor can be expressed as, a simple definition, overdrive factor is nothing but a ratio of the actual base current divided by the base current required to move the transistor into the saturation region. Okay, so if you check here, base current IB upon base current required to operate in saturation. So here correct option is option B. Option B is the correct option. Next, when the amplitude of the gate pulse to thyristor is triggered, you can check in our classroom notes we have given this point and we have discussed this also. Okay, so if the gate current is increased, then which time will be getting affected? The delay time will be getting affected. The delay time decreases, but what about the rise time? It will not affect on the rise time. Rise time depends on the load parameter. Okay, so therefore the answer is the delay time would decrease, but the rise time remains unaffected. Option C is the correct option, right? Next, a single phase full wave bridge rectifier circuit is fed from 220 volt 50 Hz supply. It consists of 4 diodes, so it is a full wave uncontrolled rectifier. A very large inductance and the load resistance is 20 ohm. Load current is a constant. What is the average or a DC output voltage? Yes, V0 average for single phase full wave uncontrolled rectifier, it is equal to 2 Vm upon pi. Alright, so it is 2 into Vm is 220 root 2 upon pi. If we simplify it, we will be getting it as 198.165 volt. Alright, so correct option is option C. Option C is the correct option. Next, in a single phase full wave controlled bridge rectifier with a source inductance and RL load, the output voltage during overlap is equal to. It is a source inductance effect on a single phase full converter. So we know during the overlap angle mu, all the 4 thyristors will be in a conduction mode. And when all the 4 thyristors conduct, then what is the output voltage? Output voltage is a 0. Alright. So correct option is option C. Very simple question. Next. If a step down chopper operates in a continuous conduction mode with a duty cycle D, the ripple factor is, he is asking ripple factor. Yes, we know in a case of step down chopper, V0 average is equal to D into Vs. V0 RMS is equal to under root D into Vs. Alright. So form factor, FF is nothing but a form factor, is equal to V0 RMS upon V0 average. So if you take the ratio here, we will be getting it as 1 by root D. That is a form factor. But what is the ripple factor? Ripple factor is equal to under root form factor square minus 1. Okay, so it is equal to under root 1 by D minus 1. This can be written as under root 1 minus D upon D. We can multiply numerator and denominator with a D, right? So we can write it as under root D into 1 minus D upon D square. So it is equal to under root D minus D square upon D, right? Under root D minus D square upon D. So here correct answer is option A. Option A is the correct option. Alright. Next. When a separately excited DC motor is to be controlled from a 3-phase source for operation in the first quadrant only in the first quadrant he is saying, only which one of the following converters is used? Yes, we know 3-phase dual converter gives 4 quadrant operation, but he is asking only first quadrant. Okay, so 3-phase semi converter, yes, 3-phase semi converter V0 average is proportional to 1 plus cos alpha, so it gives only 1 quadrant operation. What about the 3-phase full converter? 3-phase full converter gives 2 quadrant operations. Alright, yeah. Next, a wound rotor or slip rings asynchronous. Slip ring asynchronous means slip ring induction. Motor is commonly used as a drive in overhead cranes and load equalization. Which of the following speed controls is adopted? Yes, in the case of slip ring induction motor, the speed control method preferred is a static rotor resistance control, right? With the help of choppers we are doing it. Okay. Next, which one of the following statements is correct in series resonant converters? Yes, in case of series resonant converter, your load current depends on the load nature, that is a damping factor, but load voltage is independent. The output voltage waveform does not depend on the damping factor of the load. So option D is the correct option. Which of the following switching techniques are commonly used or opted in resonant converters? Very famous. In case of resonant converters, we are having the 2 switching methods, 0 voltage switching and 0 current switching, that is ZVS and ZCS. So option C is the correct option. Very simple question. Next, the function of static transfer switch in a multi-modular uninterruptible power supply, that is UPS system, is to change over. The transfer switch in a UPS system is used, yes, to change over the power supply to the critical load from UPS to the power line. That is to make the transfer between the power line and UPS. Okay, that will be connected to the load, right? So friends, these are the questions from subject power electronics. Now I would like to request the next faculty member, Krishna Reddy sir, to discuss the questions on power system.
Hi, myself Krishna Reddy. Welcome to ESE Online. Now I am going to discuss the questions for power system subject. Let us observe this first question. So what is asking here is, in HVDC transmission, high power factor in the system is maintained for which of the following reasons? So if you are maintaining the high power factor, so P is equal to VI cos phi, So from this, I value is nothing but P by V cos phi. So if the power factor value is high, the current value will be less. So the power loss that is taking place will be less. So if you observe the options here, so this third option will be the right one. For the same power to be transmitted, current rating of the system is reduced and copper loss in the AC lines will be reduced. So option 3 is the right answer. Come to the next question. So which type of hydro turbine is totally embedded in the fluid and powered from the pressure drop across the device? Impulse turbine, reaction turbine, squirrel cage turbine only, both impulse and reaction turbine. So here straightforward answer. So answer is reaction turbine. Now observe this question. Static wear compensator is usually used to design to operate at. So where static wear compensator is designed to operate at what power factor? So here it will be designed to operate at leading power factor. Now observe this question. Which of the following statements is not correct? Okay. So observe this not. So which of the following statements is not correct? So corona loss in the middle conductor is more as compared with the two outer conductors. It is right. The corona loss is less in hilly areas than plain areas. So our option is this B, because whenever you are going for the hilly areas, the corona loss will be more. So what he has stated, corona loss in the hilly areas is less. So that's what the wrong statement. Now let us observe this question. For economic size, the ratio of outer diameter of the conductor should be E. So what is saying? The ratio of outer diameter of the conductor should be, outer diameter to the conductor diameter should be E. That means capital R by small r value should be E. And what is the overall economical diameter of a single core cable when metal sheeted for a working voltage of 85 kV and dielectric strength of 65 kV. So here the maximum stress E maximum is nothing but V by R ln of capital R by small r. So what you get here, E max value is nothing but, E maximum is nothing but V by small r. So from this small r value you will be getting as V by E maximum. But what is asking to find? The overall diameter. What is the overall diameter he is asking to calculate? So overall diameter is nothing but D is equal to 2 times capital R. So from this, what is the value of capital R? That is nothing but 2 times E into small r. So if you substitute the value, you will be getting it. Now observe the next question. What is the impedance being calculated for an alternator which measurement parameter requires series connection of windings of the stator? So whenever you are going for the zero sequence impedance, generally we will be connecting the series connection. So this is the neutral Xg0 and neutral to ground. Here we will consider it as what? 3xn. So this is a stator winding is connected in series. So we can say this option is zero sequence impedance. Now let us observe this question. What is the percentage increase in bus bar voltage required to compensate the reactance drop when the feeder is having a reactance of 5%? So here feeder reactance X is given as what? 5%, and it carries a full load current at 0.8 lagging power factor. So cos phi value given as what? 0.8. So cos phi is given as 0.8 means sin phi will be how much? 0.6. Sin phi is 0.6. So what is the drop here? Vs minus Vr can be written as I into R cos phi plus XL sin phi. So here resistance is not mentioned. So we will consider the resistance value as 0. So here it is nothing but I into XL into sin phi. So here what is given? Reactance given as 5%. So the answer is nothing but 5% multiplied with 0.6. So it will be 3%. Now let us observe this question. Overcurrent relays are categorized, obtaining their characteristics under. So this is a general question that we can observe. So this A represents the definite time characteristics, whereas this is the definite time characteristics. We can say B represents the IDMT characteristics. So in the question, what is asking, the curve B in the table is representing what? It represents what? Inverse definite minimum time characteristic. Now let us observe this question. Consider the following statements. So arcing time of a arc controlled circuit breaker varies considerably depending upon the breaking current. And the second option is, except for certain medium range of voltages, air circuit breakers are used for low voltages as well as high voltages. And resistance switching reduces to help in uniform recovery voltage across several gaps. And the third question, what is saying, by using a better insulating materials in oil circuit breakers, it will meet the increased fault levels in the system. And resistance switching reduces the transient voltages during the switching out of inductive and enhances for capacitive. So if you observe these options, option A will stand right here. So he is saying not correct. Observe this statement. Which of the following are not correct? Now observe this question. Consider the table below for different types of buses where each set may consist of voltage, real power, reactive power and load angle. So as we know here, load bus given, slack bus given and a generator bus given. So here known quantities and unknown quantities. So basic question here, for load bus the known parameters will be P and Q. We need to calculate V and delta. For slack bus the known quantities will be V and delta. We need to calculate what? P and Q. For generator bus known quantities are P and V. We need to calculate Q and delta. So here he has specified as what different sets. This is what set A and this is B, this is set C, set D, E and F. So simply time consuming question. So if you observe the statements, set A and E are same, yes or no? This is set A and set E resembles the same, but set C and D are different, yes or no? Set C and set D are different. So option A is the right one here. So in this option A is the right answer. So now observe this question. While the load flow equations are non-linear and they are solved by using Gauss-Seidel method. So Gauss-Seidel iterative method is used including the PV buses, and what is asking, what would be the reason for violation of reactive power limit? So why the reactive power limit may get violated? So either too low or too high specified voltage values will result in the violation of reactive power limits here. Okay. Now observe this question. So consider a system consisting of synchronous machine connected to an infinite bus bar. The below power angle curve is obtained using the equal area criterion. So this question is related to equal area criteria application. Sudden increase in mechanical load on motor occurs. So what is asking, what is the condition of power at point B? So at point B, what is the condition? That's what he is asking. So if you observe at point B, both mechanical and electrical inputs are same. P is same as PS. So now observe this question. 345 kV transmission line feeds a distribution system that in turn has a radial feeder that feeds to a 4160 by 2400 volts transformer, 4-wire distribution network, and the turns ratio of delta star connected 100 MVA transformer. So what he is asking, what is the line current in the delta side he is asking. So here as MVA rating will be same, this is 100 MVA, transmission line is 345 kV. So here we need to calculate the line current. S is what? Root 3 times of VL IL. So from this IL value is what? S by root 3 times of VL. So here S value given as how much? 100 MVA, 100 into 10 power 6 by root 3 times of, what is VL here? Voltage given is 345 kV, 345 into 10 power 3. So if you simplify this, you will get it as 167.35 amperes. So that's all from power system side. Next faculty will be discussing about electrical machines.
Hello. Yes, good evening everyone. In the today's paper from electrical machines, we got little less questions only when compared to the previous years. So around 14 questions we have from total electrical machines of 4 parts. Okay, so let's see one by one. If Ts represents shaft torque and Te represents electromagnetic torque, and if these are assumed positive for a generator, okay, so in a generator it is, the net torque causing acceleration torque is dash. So what is the resultant torque? So in a generator, the electromagnetic torque developed will be in the opposite direction of prime mover torque. Suppose we are rotating the prime mover clockwise, that is called shaft torque here. So what is the accelerating torque here, resultant? So we get the accelerating torque or resultant torque is Ts minus T. Okay, shaft torque minus electromagnetic torque, because these two are in opposite direction. Next question. So what is the answer here? Ta equal Ts minus Te, option A is correct. Okay, next question. See this. The magnetic cores of large transformers are built in stepped. So that is, if you consider the cross section of the limb, so we have two types of cross section. One is called square core cross section and stepped core. Stepped core we also call cruciform core. So why we use stepped core? So we create steps at the corner of the square, so that due to these steps, mainly the diameter. So if we create steps at the corners like this, let so like these steps are created. So because of these steps at the corner, mainly what happens here is, if you consider one turn here, so one turn when compared to square core cross section, this diameter will reduce here. So as this diameter is reduced, so what happened, mainly insulation required reduces and copper requirement also reduces, because for each turn the copper required will be less. Then if there are 1000 turns, so much of copper will be saved. So when copper is saved, automatically losses also reduces, because of that copper is less. That's why the main purpose is to minimize the use of copper and decreases copper loss. So option C is correct for this. Okay, next. An auto transformer has an advantage over the equivalent two winding transformer. So what is one of the advantage of auto transformer over two winding? So what is that? No electrical isolation. So is it right? No, because that is drawback for us. In auto transformer, no electrical isolation, that is a drawback. So here, greater short circuit current, higher excitation current, and lower leakage reactance. So what is the answer for this? So in auto transformer, we know leakage flux is less. So whenever leakage flux is less, automatically leakage reactance also less. So leakage is less here. That is an advantage in auto transformer. So due to that, voltage regulation of auto transformer also reduces, that is voltage drop reduces. So option D is correct for this. Okay, next question. The stator and rotor slots of asynchronous motor, that is induction motor, are designed to traverse the axial length of the magnetic core, at an angle from the true axial direction. So true axial direction, nothing but if you consider shaft, the rotor slots are designed such that the slots are exactly parallel to the shaft axis. That is normal rotor. But here there is some angle created. That angle is nothing but skewed angle it is. So this is simply related to the skewed rotor. Okay, read here. The average value of MMF wave over the axial length of the magnetic core. If it is not skewed, that average MMF shape will be straight line. But as it is skewed here, so we get a ramp shape here, that MMF shape is traversed as, our transition is ramped transition it is. That's why answer is option B, ramped transition. Okay, next question. A 4-pole 50 hertz 3-phase asynchronous motor. So whatever the questions we got mostly from machines, direct questions, there is no difficulty, and except 1 or 2 questions there are some confusion. That is also properly not created that options, particularly in transformer cities. Okay, see this. A 4-pole 50 hertz 3-phase asynchronous motor is operating at a shaft speed of 1750. So which is more than synchronous speed. Okay, because 4-pole is given 1500 RPM is the synchronous, but shaft rotating at 1750 means more than synchronous. Maybe induction generator operation it is. Okay, what is the speed of the stator air gap MMF? So stator MMF speed, what is the stator MMF speed? Nothing but synchronous speed. What is the synchronous speed directly? 120 F by P. So that is 1500 because directly for 4-pole 1500 RPM we get. But they are asking the options in radians per second. So what is omega s? 2 pi n by 60. So calculate this, we get how much it is? 157.07 radians per second. So that is option B is correct. Next question. Prior to placing a 3-phase star connected synchronous generator in service, so that is to operate in parallel with existing system. Existing means grid. So before connecting this generators, read the question. In service on star connected electric utility grid, 3 lamps are connected across the open contactors served as indicators to assure synchronization conditions. If the lamps will blink off and on, which indicates. So they connected 3 lamps across generator and grid system. Now these lamps are having blinking, that is off and on. So they are becoming dark and bright, dark and bright. So whenever lamps are becoming dark and bright or they are flickering, it means flickering, on off, on off. So whenever lamps are flickering, nothing but definitely frequency is different. Maybe if phase sequence suppose different, let us consider phase sequence different. But whenever phase sequence only different, assume that frequency is same, then you don't get any flickering. Maybe all the 3 lamps will not show equal bright or equal dark at same time. They may show different brightness, different darkness, but same will be there continuously. There is no off and on. That is flickering will not take place. So flickering will take place only whenever the frequency of the 2 systems are different. Remember this. That's why we can go the frequency of oncoming synchronous generator and the electrical utility are not equal. If they are equal, no flickering. As frequency different, as frequency is not same, that's why it is flickering or on off is getting. Okay, option B correct for this. Next question. A primitive stepper motor and its digital driver circuit is furnished with a train of F pulses per second, frequency given. So okay, it is operated with a frequency F PPS, pulses per second, that the input of the controller is divided so that the output is sent in sequence to one phase winding at a time with 2p as the number of phases in the rotor and k number of T's we have in the rotor. Then the rotor angular motion per pulse is a step of dash. So simply in this question we need to find step angle. What is the step angle made by this rotor in each step or in each pulse? So what is the formula for this? So let it is beta is equal to 360 divided by m into PR. So this is direct formula, it is 360 by m is the number of phases. How many phases given? 2p phases given. And number of rotor teeth that is given as k number of teeth. Then we get 180 divided by kp. But they are asking options here in the radians. So what is in radians we can call it is pi by kp radians. Pi by kp. So answer is option D is correct. Pi by kp for this. Okay. Next question. When there is no ferromagnetic material but only air is present in between the coils or 2 windings, such a transformer is called dash. If there is a core, we call core type transformer. If there is air, we call air type transformer or air core transformer we call. But here iron core is given, steel is given, so these two definitely we can strike out. These two definitely we can strike out. Wet type, dry type. So wet type and dry type based on cooling we call it is. If there is no oil in the transformer, that is called dry type. If there is oil in transformer, we call wet type. So that is different. In dry type also we have core, but here it is not given mentioned clearly. Based on the options we can expect it is a dry type transformer, or we have to call it is air core transformer particularly. Okay, just keep in mind it is air core transformer it is. Next question. The objectionable, audible, humming sound in the core of transformer due to magnetostriction is minimized by dash. How can we minimize humming noise in transformer? So we have some methods there, by tightening the core clamps, by tightening the laminations with the clamps tightly, and by operating at low flux density. If you operate at low flux density but not less flux magnitude, so from the given options here we have by decreasing the flux density. By decreasing the flux density. So whenever flux density decrease, magnetostriction decrease. What is flux density? Bm proportional to flux per area. Now in order to decrease flux density, if you consider flux decreases, flux we should not decrease. We should not operate at low flux density, low flux. We have to operate, or we have to use maximum flux, so that effective utilization of core will be there. For that we can increase little area of cross section, then density reduces. Whenever density reduce, magnetostriction reduce, then automatically noise also reduce. So we can go with decreasing the flux density. And if you see here, use of stacking lamination, use of silicon steel sheets, both are almost same. Silicon steel also will stack or staggered. Okay, both are same it is. Next. The ideal two winding transformer, primary and secondary turns N1 given, N2 given, with a mutual coupling flux described by the parabolic function given. So one flux equation given here. Now we need to find the primary terminal voltage. Primary side terminal voltage means what? Supply voltage. First let us find what is EMF induced on primary. According to Faraday's law completely, we can write minus N1 d phi by dt. Okay. So minus N1 is 100 turns, minus 100 into d by dt of flux. So this is minus, minus minus become plus here, directly I am writing plus, and 0.05 into, this is 2t, minus 2 is 2, 2t minus 2, 0.05 into 2t minus 2, okay. Then we get it is 10 into t minus 1. So this is what E1 it is, but they are asking primary terminal voltage. So primary terminal voltage will be, what is V1 equal to? Minus E1. So this EMF is opposing, so we can write minus E1, this is minus 10 into t minus 1. So that is option minus 10 into t minus 1. Option B is correct. Okay, next question. A 4-pole, so this is the only question we have in DC side, DC machine. A 4-pole lap 1 DC machine armature has 54 slots. So the number of slots equal to 54, and it is having single turn coil. Single turn coil means each coil having one turn only. Then each coil side means one conductor it is. Okay. Each coil side in single turn, nothing but one conductor itself directly. How many armature conductors are required? If there are 2 coil sides per slot. 2 coil sides per slot is nothing but double layer winding it is. Now in one slot we have 2 coil sides like this. And each coil side having one turn, that is each coil one turn. One turn has 2 conductors. Now this is one conductor, this is another conductor. So directly we can say in one slot we have 2 conductors. One slot having 2 conductors. Now total conductors equal to 54 slots. 54 into 2, nothing but 108. So these are the total conductors. Okay, next. See the statement 1. Transformers take advantage of the high magnetic energy density of ferromatic material to allow economical device design. However, the non-linear nature of ferromagnetic materials leads to introduction of harmonics in current and voltages. So this is right. So due to non-linearity, which non-linearity? We have saturation non-linearity and also hysteresis non-linearity. So due to that we will get harmonics in this current and voltage signal. So this statement is right. Statement 2. Non-linear nature of the transformer magnetizing inductance can lead to transient inrush current significantly greater than the rated value of current upon energizing a transformer. So whenever we energize or supply is given, then during switching transients, we get this magnetic inrush current due to magnetic energy stored due to inductive nature of the windings. So this is also correct. But this statement individually true, but it is not correct explanation for statement 1. Okay. Next. So for this, both are true, and it is not correct explanation for statement 1. Option B is correct for this. Next. Isolating transformers are commonly used in many types of electric circuits for the purpose of dash. So isolation is 1:1 transformers we use mainly for protection purpose for individual loads. Now what is the main purpose is? It is to block direct current signals, DC signals, while maintaining alternating current continuity between the circuits. Option C correct for this. Okay. Next. A 3-phase balanced star connected motor draws a real power of 5.6 kilowatt. So motor is taking a power of this much, 3-phase, okay, from the line voltage of 220 volts and a line current of 18.2. What is the approximate power factor? So direct question it is, what is the active power equation in 3-phase? Power equal to √3 VL IL cos phi. So all values directly given, the only unknown is power factor. So power is 5.6 K divided by √3, line voltage 220 and line current 18.2. Then solve this, we get power factor 0.807. So direct solving. So option B is the correct answer for this. So these are the questions from total electrical machines. Next, the subject is network theory. Verma sir will continue.
Yes, my dear friends, how would you have written? Definitely good. Okay, we are there to give you the detailed explanation, but most importantly, how to write in less than 1 minute. There is only one question in circuits, we call electric circuits. Network theory is the name given for electronics and telecommunication. There is only one question which is a trap, don't attempt it, which I will discuss. Otherwise, rest of them are very easy. Now see this. The current waveform shown in the figure, what is the average value over the time interval of first 7 seconds? What is the average value up to first 7 seconds? Now average value integration 1/t integral 0 to t, no need. Integration of any function over a period represents area, so area by time period. But here positive area is there, negative area is there. So here V average is, or I average is, I will say it is I average is, because it is current is net area by time period. Chalo, positive area, everybody see now, positive area, here length into breadth, okay, 2 into 3/2, okay, 2 into 3/2, that is 3, okay, plus here length into breadth, that is also 1 into 1, 1. So total it is 4 units positive. When it comes to negative area, you see this is the negative area, length into breadth 2 into 2, that is also 4 units. So here positive area equal to negative area, net area is 0, net area by time period is 7, so 0 amps. So option is C, option is C, okay. So that is the faster way to do. Now see here, the unknown currents I5 and I3, right, KCL, unknown current KCL, unknown voltage KVL. If that is not possible, mesh, nodal theorems are there, but no need. See, if I write KCL at this node A, incoming current is equal to outgoing, incoming 10, okay, is equal to outgoing 5 plus 3 plus I5 plus 3 plus I5. So I5 is 10 minus 8 2 amperes, I5 2. Then KCL at node B, incoming is equal to outgoing, incoming 5 is equal to outgoing I3 plus 4, I3 plus 4. So I3 is 1 ampere. So I5 is 2, I3 is 1. Option A respectively, see I5 and I3, I5 and I3, 2 and 1, option A, the easiest bit. Now see here, I was talking about this question. This is an absolute trap. My suggestion, if I am writing exam, no, don't attempt this. Don't attempt, it will save hell of a time. I had applied superposition, I applied Thevenin's, I applied so many ways, there is no other option. But if I write the nodal equation, now see, if I take this as reference and keep writing so many big equations, this current plus this current plus this current, VA minus 10 by 5, VA minus VB by 8, VA minus VC plus 20 by 4 is 0. Second equation, VB minus VA by 8, VB by 20, VB minus VC by 10. This is VC by 25, VC minus VB by 10, VC minus VA minus 20 by 4. If you keep solving, you will get a system of equations. But at least I will give you the solution. The system of equations will be 23 VA minus 5 VB minus 10 VC is minus 120 minus 5 VA plus 11 VB minus 4 VC is 0, and the third minus 25 VA minus 10 VB plus 39 VC is 500. Sir, who will solve these nonsense equations? And that too in IES. Even conventional I wouldn't have preferred. But after solving, you are getting this VA as 4.34 volts. Now this current through 10 is 10 minus VA by 5. So the current through, okay, that current through 5 ohms, okay, that current through 10 volts or 5 ohms is 10 minus VA by 5. You are getting somewhere around 1.132 ampere. 1.132 is option C. Option C. But this is a trap. There are so many bits in every subject. There is an absolute trap. So don't attempt. That is a way. But this is the accurate solution. 1.132 amperes. Okay. Now rest of them are very easy. Now this is a beautiful problem. He wants Thevenin's resistance only. See, I teach there are 3 categories in Thevenin's. Only independent source, category 1. Both independent, dependent, category 2. Only dependent, category 3. Actually here independent, dependent are there, category 2. But in category 2 we get VOC by ISC. VOC is Thevenin's voltage, ISC is not, that ratio is resistance. But that is a long method, sir. What you do to find only resistance? Because only resistance, deactivate and apply Ohm's law. Deactivate and apply Ohm's law. So if I deactivate, see this I will short. Which element to deactivate? Independent source. So remove this. So 10 volts is removed. Now apply Ohm's law. Now what you do? Here I will give voltage and find current. So let me give 1 volt and I will find I total. Watch this carefully, sir. Let me give 1 volt and I find I total. When 1 volt is given to 200, this is 1 by 200. Okay. And when 1 volt is given, yes, yeah, when 1 volt is given to 200, this is 1 by 200. And when 1 volt is given to 2000, this is 1 by 2000. So automatically I is minus 1 by 2000. If I is minus 1 by 2000, this is 9 by 2000. 9 by 2000 going down. Chalo, now sir, everybody, if you apply KCL, incoming I total is equal to outgoing. This is 9 by 2000. Okay, this is 1 by 200. Ohm's law, sir, this is 1 by 2000. 1 by 2000. So I total is, okay, I total is, you will get this as 10 by 2000. Yes, this is 10 by 2000. Okay, plus 1 by 200. So I total you will get it as 1 by 100. So the RTH is 1 volt by I total Ohm's law, that is 100 ohms. 100 ohms. 100 ohms. Option C. Okay, option C, 100 ohms. Okay, na? So this is actually VOC by ISC, but only resistance do like this. Deactivate, that is the faster way, 1 minute. Remove the independent. Deactivate means which source, independent source you remove. Then apply Ohm's law by giving 1 volt or 1 ampere. Here I gave 1 volt, I got I total, ratio is 1 ampere. That, yes, 100 ohms. Now see this question. Now this is again slightly controversial. He said this is the load resistance and it can be adjusted. And later he told it is adjusted to 10 ohms. There is a controversy here. An experimental circuit is shown below with a variable resistance RL. One way he told variable resistance RL. And if variable resistance is RL, we know maximum power occurs in the load when load resistance is source resistance. But he did not do that. Variable resistance RL, which is adjusted to the value of 10 ohms, he told again. So this is slightly controversial, but he told that this is again adjusted to 10 ohms. 10 ohms. And what is the maximum power? So when this is fixed, the only power is current square into R. Now this is 10, this is 30. Total resistance is 40. 10 by 40 is 1 by 4. So current square 1 by 4 square is 1 by 16 into 10. So power is, or P max is 1 by 16 into 10, that is 10 by 16, which is 0.625, that is 625 milliwatt. 625 milliwatt. That is the only option. That is the only option D. So there is slightly controversy. He said it is variable, but it is fixing to 10. That is a meaningless. Okay, but answer is yes, 625 milliwatt. Okay. Then sir, this is one of the best questions, sir. Again, without calculator, how to do in 1 minute. He told this is 100 volts. Now switch is moving from 1 to 3. 1 to 3. Previously it was in the previous DC steady state. It would have charged to 100 volts. Now here it becomes source free first order RC. Source free first order RC, this voltage across capacitor, this voltage is V0 e power minus t by tau. Okay, all this is there, V0 e power minus t by tau. But finally, you listen now, he said that how much time it will take to reach 5 volts. Very interesting, sir. How much time final value is 0. How much time it will take to reach 5 volts? Initial value is 100 because previously it will charge to 100. What is the time constant? Time constant tau is RC. RC. R is how much he told? R is how much? 10 kilo. 10 kilo. C is how much he gave? 0.005 micro. Okay, R is 10 kilo. Capacity is 0.005 micro. If you take the product, yes, this is 0.05 milliseconds. But that is nothing but 50 microseconds. Chalo sir, now this is the logic. Time constant I got. Time constant I got. But how much time it takes to reach 5 volts? Now sir, in source free response, if it is V0 e power minus t by tau, you know, at t equal to 0, it is V0 100. At t equal to tau, that is nothing but e power minus 1 V0, that is 0.367 V0. At t equal to 2 tau, it is e power minus 2 V0, that is 0.135 V0. And at t equal to 3 tau, it is e power minus 3 V0, 0.049 V0. This I teach in my class, in my notes it is there. Everyone can refer that. Now see this. That means system would have reached almost 5% of its initial value in 3 time constants. That is the logic here. System would have almost reached 5%, 0.04. System final value is almost 5% in how many time constants? 3 time constants. Time constant is 50. Okay. He said it will reach 5 volts in how much time? 5 volts is 5% of initial value. That will take 3 time constants. So 3 time constants of this is how much? T is 3 tau, which is 3 into 50, 150 microseconds. That is a logical way. 150 microseconds. Okay. Option D. You do with exponential function, you cannot get. Without calculator, you cannot get. So the nearest, yes, the correct is 150. Okay. 3 time constants, almost it will reach 5% of the original value or initial value. Then see, this is a star. This is a star. Y means star connected generator designed to supply 20 kilovolts 3-phase line voltage and supply current of 10, lagging power factor. How much reactive power will the generator supply? Reactive power. We know reactive power in a balanced system, reactive power is √3 VL IL sin phi, not cos phi. √3 VL 20K IL 10, line current L, okay, sin phi. Cos phi is 0.8, sin phi is 0.6. Now if you observe, kilo you take out, this is 6. 120 into √3, 1.732 kVAR. Now again without calculator, how? See, this is 1.7, that is 73%, almost 70%, 75 you take. See, 75 of this is how much? 80. Okay, 75 of this is almost, you know, so it is going to, almost it is coming near to 210, near to T10, near to 210 is this one. That way you do. See, there is no calculator required, you see nearest. Actually it is 120 into 1.732 kVAR. Another 70, near to 75%. Okay, that you take 75%. Yes, if you do that, yes, it is coming to this. So 90 plus 120 is near to 210. Nearest answer is this. No calculator, please. Okay, option is B. Okay. Now see here. Now this is the only unique bit I saw in circuit which is something special. See here. A cross-sectional view of a printed circuit board consisting of 2 conducting lands on the surface of dielectric board above a surface ground plate is shown in the figure. Okay. So he said this is a printed circuit board where this is the ground and these are the pins. Okay. The 3 conductor system is characterized by a partial capacitance scheme as shown in the figure. Okay, this is a partial. So this conductor capacitance, capacitance to ground he gave. Okay. For the multiple conductor system, what is the capacitance matrix? I was really stunned. What is capacitance matrix? Write KCL. So he is giving some term to confuse. we know Z parameter, Y parameter, H, but it is asking capacitance matrix. So my simple meaning is write KCL, and from that KCL write Ohm's law form, I is C dV by dt, and we can get capacitance matrix. Now see, watch this carefully. So yes, this is like what I am doing, just observe here. This is like node 1, node 2, okay. Now this is like V1, this is like V1 which is allowing total current I1. This is like V2 which is allowing total current I2. Now if I write KCL here, I is C dV by dt. So this I1 is, everybody, this I1 is, okay, C dV by dt. This current plus this current. What is this current? C dV by dt. That is 6 nano dV1 by dt. What is this current? Plus 2 nano into, this is difference na, dV1 by dt minus dV2 by dt. So if you observe, this I1 is 8 nano dV1 by dt minus 2 nano dV2 by dt. That is the first equation. If I go to the second equation, everybody, if I write the second equation, this current is this current plus this current. Again, what is I2? I2 is this current, 3 nano into dV2 by dt plus what is this current? 2 nano into dV2 by dt minus dV1 by dt. So if you write again, I2 is minus 2 nano dV1 by dt plus 5 nano dV2 by dt. So now if you write these two equations in matrix form, capacitance matrix. So what is the capacitance matrix now? I is C dV by dt. If you write, you see this 8 nano minus 2 nano, this is minus 2 nano, 5 nano. So this I is C dV by dt, this is the capacitance matrix. So he is just testing fundamentals like KCL and KCL, especially KCL and Ohm's law. So the capacitance matrix is 8 nano minus 2 5. So answer is option D. Option D. Very interesting, na sir. So printed circuit board matrix, capacitance matrix is asking. Now, yes, a circuit composed of series combination of sinusoidal voltage source and a 500 ohms and 30 millihenry inductor. So he said there is a resistance, okay, in series with voltage source, and there is also inductor, okay, and there is also inductor. I would like to say, okay, and there is an inductor. Now he is asking how much should be the load impedance ZL for which Pmax occurs. What is this voltage? Okay, he gave resistance is 500 ohms and inductor is how much? 30 millihenry. Now here this is the source, okay. Now he said total impedance, total unknown impedance. Now that means this is general case or special case ABC? General case. Total impedance variable means general case. In general case, Pmax occurs if ZL is ZS star, complex conjugate of source. But what is ZS? ZS is RS plus JXS. RS, what is source? 500 plus JXS. XS is omega L. Omega is 100. Omega is 100. L is 30 milli. Chalo, done, sir. So this is nothing but 500. If you do that, that is nothing but plus J3. But what is the final answer? ZL is ZS star, which is 500 minus J3. 500 minus J3 is the answer. 500 minus J3, option C. Option C. Okay? Chalo, with this, yes, circuit theory is perfectly done. Now I would request electrical measurements sir, Ramesh sir, to take over. Okay, sir? So I hope you would have written better, but we are always there to guide you further. So please join ACE Academy and ACE Online for more quality, okay, in these competitive exams. Thank you.
Hello everyone, this is Ramesh. Now I am going to take the questions from electrical and electronic measurements. Surprisingly, almost all the questions are from only electrical measurement this time. The first question here is, it is related to 2 watt meter method. It is related to 2 watt meter method. Straight away question from the classroom, that is, here P1 and P2, 2 watt meter readings are given. What is the per phase reactive power? He is asking per phase reactive power. Straight away, sir, Q3 phase, we know that Q3 phase is equal to root 3 W2 minus W1. So therefore, root 3 W2 is 2500 minus W1 is 1500. We will be getting 1000 root 3 VAR. This is the Q3 phase, but what he is asking, per phase he is asking. So therefore, Q single phase is equal to 1000 root 3 by 3 times. So therefore simply we will be getting 1000 by root 3 VAR. So 1000 by root 3, how much you are going to get answer? Approximately, yes, 577.3 anyway VAR. It's a simple formula based question. Now, the next question is, it is a conceptual one. Which one of the following is used to protect standard cell and galvanometer against the overcurrent? It is a straight away one. If you want to protect anything, in with respect to the overcurrent notation, a resistance must be connected in parallel automatically. So therefore, straight away option is D option. Right. The next question here is, right, in a measurement of low resistance, it is also, right, same model from the classroom, but only values are being changed here. That is, here, what are the values given? Measurement of low resistance using potentiometer, okay. Voltage drop across low resistance under test. So therefore, unknown resistance voltage is 0.4 volt. Voltage drop across standard resistance is 1 volt, and standard resistance is given as 0.1 ohm. Right? Now, sir, VR by R is equal to Vs by S. Sir, VR, Vs and S all are given. So let us find out the R value. VR 0.4 by Vs 1 into 0.1, you will be getting 0.04 ohm. This is a general value, but he is asking power loss in the unknown resistance. He is asking one more step. So power loss in the unknown step is simply voltage square by resistance. What is the voltage square? 0.4 square by value is resistance is 0.04. If you simplify this, you will be getting the answer as, right, 4 watts. You simplify this, the answer will be 4 watts. Right. Next question is, consider the following statements. It is a conceptual one. Here both statements are almost similar, but small change is there. Potentiometer is the usual basis for calibration of voltmeter, ammeter, wattmeter. Yes, potentiometer can be used for calibration of all. Yes, it is correct. But potentiometer may not be used for measurement of current, power and resistance. No, we can measure current, power and resistances normally. So therefore, according to the question, what is that? Only first statement is correct. Right? Next question. A simple slide where this is the question straight away from our classroom. Right? Classroom question. As it is available in our AS material also. The question here is, simple slide wire potentiometer used to measure the current in the circuit. Yes, the straight away question is used to measure the current in the circuit. So therefore, we can say that potentiometer may not be used for measurement of current. Is wrong statement only. In the question only answer is there. And here, this is the slide wire, right? What is the length? 75 centimeter and 0.1. This is A and this is B. 75 centimeter and 0.1 ohm, right? And the corresponding which element, right? Standard cell of 1.45 volt is placed at, right, 50 centimeter and the balance is obtained. It is placed at 50 centimeter and the corresponding balance is obtained. Now he is asking what is the working current. So therefore, sir, what is the working current? Very simple. Sir, the galvanometer is showing 0 means same 1.45 is across this. So therefore, VAC is equal to 1.45 volt and sir 75 centimeter is having 0.1 ohm and 50 centimeter how much? If you simplify that, you will be getting RAC value as 0.0667 or approximately 0.067. If you simplify this, IW equal to VAC by RAC, that is straight away you will be getting 21.75 amperes. Yes, this is the answer. As it is question from our classroom. And one more question. Which of the following methods is not used in measurement of high resistance? He is asking not used. Don't get confused. If you are not observing this, you may be selecting this one. Direct deflection method is high resistance. But he is asking not used. So therefore, what is the point here? Direct deflection method, meg ohm bridge, megger, all are used for high resistance. So Kelvin double bridge method is not used for high because it is low resistance measurement. Right? Next question. Which of the following is intended for the rapid measurement of the winding resistances of machines and transformers? Here small confusion will be there. Sir, winding resistances in the corresponding machines and transformers will not be very infinite value, etc. So that's why based on that we can say, sir, ohm meter is the better answer for this, right? So this is for megger, very high resistance, etc. This is for medium, okay, but here it is most rapid measurement. So therefore simply ohm meter or resistance meter is a general answer. Right, next question. A highly sensitive galvanometer can detect. This is a somewhat lengthy numerical question. I'll give the hint, I'll give the answer, then you can go for the detailed solution in our site. The point here is, here the current value 0.1 nano ampere, the galvanometer used in the Wheatstone bridge as a detector. Each arm of the bridge has a resistance of 1 kilo. The input voltage applied to the bridge is 20 volts. So therefore simply I am giving the idea. This is the corresponding bridge, right? Each resistance is 1 kilo ohm, 1 kilo, 1 kilo, every resistance is 1 kilo. This is 20 volt, that is E, right? So from this we need to find out RTH. You know, find out RTH value, short this and look in from this side. So simply, right, you are supposed to look from this side. This is RTH. If you are finding the RTH, you will be getting 1 kilo ohm. And after that, if you are simplifying the corresponding V0 value, or we can say VTH value, right? In this only one branch is getting changed, he has given. So therefore, 1 by 4 E into delta R by R will be there. If you simplify this, you will be getting the value as VTH as delta R by 200 will be there. But what he is asking, how much resistance for this current, how much resistance is the value. So therefore, sir, VTH is there, and then simply Ig is equal to VTH by, what is the value? RTH. If you simplify this, you will be getting the value as delta R value as, simply you will be getting 20 micro ohm. So this is a straight away answer, 20 micro ohm is the answer. Only what we are supposed to find out? The RTH value, VTH value, then we are supposed to find out Ig value, current to the galvanometer, VTH by RTH notation. Right? Next question. Which one of the following methods is not used for measurement of low resistance? Very simple. Right? Measurement of low resistance is done by Kelvin double bridge, potentiometer method, and among these two, more suitable answer is direct deflection method is not used because this is for generally high resistance measurement. Right? Next question. A regular Wheatstone bridge is used to measure high resistance. The bridge has different resistance values are given. Right? If you apply the simple notation here, what is that? R is equal to, right, P by Q into S notation. R equal to P by Q into S. If you are simplifying this, you are going to get the answer straight away. Here, this is the answer, 10 mega ohm will be there. This is the balancing condition. If you are using this, you are going to get the answer as 10 mega ohm. And next question is, here it is also some numerical based question, right? In this also the, right? Here 3000 ohm is given, and he has given that 5 dial resistance box is given, that is thousands range, hundreds range, 10 ohm, 1 ohm and 0.1. 5 dial system is there. Actually speaking, he is asking for this accuracy, how many these dials would it be worth to adjust? Means how many dials adjusted he is asking. But he has given that resistance value straight away. So therefore, 3000 ohm and correspondingly percent, 1.1%. If you are writing this, 3000 plus or minus 0.1%, you will be getting the straight away answer as this one, right? Option here is option A you are going to get. Actually he is asking how many dials, but in the option he has given straight away, this is the 3000 ohm and this is the corresponding 0.1%. So straight away answer will be this. And Next question is, here it is little bit confusing one. Campbell's bridge measures an unknown mutual inductance in terms of standard mutual inductance. Generally in the classroom what we take, Campbell's modification of Heaviside bridge we take, but he is asking only Campbell's directly, so therefore it is correct. Campbell's bridge is used for measurement of self-inductance in terms of mutual. Yes, both are correct. So therefore, what is the answer? Yes, both 1 and 2 are correct. And next one, this is the last question. Carrier-Foster bridge is used for measurement of capacitance in terms of standard mutual inductance. So obviously, Carrier-Foster's bridge is nothing but capacitance in terms of mutual inductance. Yes, this is correct. Head-Wheeler's bridge is used for measurement of mutual inductance in terms of standard mutual. No, actually mutual inductance in terms of capacitance is correct. So this is wrong. So straight away only one is the correct one. So these are the questions from measurement subject. The next subject is computer fundamentals.
Right now we are going to discuss some part of computer fundamentals, nothing but CO subject. Now, watch this question. Which one of the following is used for recognizing the magnetic encoding numbers printed at the bottom of the check? Here, he mentioned clearly about magnetic material. That's why option A and option D are false. Right now we are going to discuss the solution in the shortest way. Detailed solution will be given later. In this, barcode reader or magnetic ink character recognition. Now, in real-time application, already we know MICR. It is printed on the below bottom of the check. That's why correct option is B. For this, correct option is B. Next question. Watch this one. A benchmark program is run on a 200 MHz processor. The executed program consists of 1 million instruction executions with the following instructions mix and clock cycles count. Here, instruction type, arithmetical and logical, 8 millions, load and store 4 millions, branch 2 million and other 4. So, for solving this question at shortest rate, here we are having one expression, nothing but 200 MHz is nothing but the given clock frequency divided by, here number of clock cycles required for category of instructions, 8 into 1, 8, 4 into 3, 12, 8 plus 12, 20, 2 into 4, 8, 28, 4 into 3, 12, in total 40, means given frequency by total number of clocks required into, in this, here total number of operations, nothing but 8 plus 4 plus 2 plus 4, nothing but 18, divided by 10 power 6 because megahertz. So in this case, million means mega, nothing but megahertz and million gets cancelled. That's why finally it is nothing but 5. Final answer is 90. Correct answer is A. Next. Question number 116. What is the exponent length in bits of IEEE double precision floating point format? IEEE double precision size is nothing but 64-bit. Entire number size is 64-bit. This 64-bit number is divided in 3 fields. Yes, it represents sign of the data. Next, biased exponent and mantissa. Total size is 64-bit. In these, S to represent S 1 bit and biased exponent 11 bits, mantissa remaining 52 bits. What he asked in this, exponent length means size of the exponent field, nothing but 11 bits. Okay. Next question. Watch this. Simple question it is. Whatever the information given, entire information is not needed to solve this one. Only 1 minute time is sufficient to get solution. Consider a main memory consisting of 4K blocks, means number of blocks in main memory. MB means number of blocks in main memory. 4K means 2 power 12. Cache memory consisting of 64 blocks and block size of 32 watts means BW, number of watts in block is nothing but 2 power 5 watts. Now, compute the number of bits in the main memory. Address using direct mapped cache. Whatever the type of mapping technique doesn't matter. He asked the number of bits required for addressing one of the words in main memory. Main memory capacity is nothing but number of blocks in main memory 2 power 12 into capacity of each block means number of words in each block 2 power 5, nothing but 2 power 17. To select one of the 2 power 17, we require 17 bits. So correct option is B. Okay, next we go for solving next question. Which one of the methods is used when the processor issues an IO command, continues to execute other instructions and is interrupted by the IO module when the latter has completed its work? Direct question it is nothing but interrupt driven IO. Because in this, external device is appointed for detecting the status of the IO device. That's why it is nothing but interrupt driven IO. If processor takes responsibility to check the device status, then it become, then programmed IO answer will become correct. Now we have completed some part of the computer fundamentals. At the same time, we are going to discuss only one question from digital subject. Watch this one. Only one question from digital subject. Simple question it is. By considering the standard notation in DAC, DAC means digital to DAC means digital to analog converter. The glitch due to the switch associated with the most significant bit can have an amplitude almost equal to. He asked the MSB voltage. He asked the MSB voltage. VMSB, MSB voltage, nothing but reference voltage by 2. Whatever the size of the ADC or DAC, only MSB is used to provide exactly half to the given reference voltage. So that's why it is direct answer B. Next, our Devankit sir will continue the same computer fundamental session. So some more subjects are connected to the same computer fundamentals. So our Devankit sir will continue the same.
So thank you, Ramaiah sir. Now guys, let's see question number 91. So question number 91 is saying which one of the following statement is correct for atomic data. Specifically, they have mentioned for atomic data. If you read option A, they are saying aggregation of atomic data and composite data. So in option A, they are again talking about composite data. That's why leave it. Option B, heterogeneous combination of data. Again, they are talking about heterogeneous, leave it. C, homogeneous combination of data. They are again talking about some unnecessary word, leave it. D, they are talking about atomic data. What they are saying, it is a data that consists of a single piece of information. That is, they cannot be divided into other meaningful pieces of a data. That is the right answer for atomic data. Let us see the next question, guys. Now, the next question is from OS. The question is saying, consider the 4 process P1 having 6 as a burst time, P2 as a 8 burst time, P3 as a 7 burst time, P4 as a 3 burst time. And then it is also given they are arrived at a time of 0. Then what is the average waiting time for these processes with the shortest job first algorithm? We have to apply SJF. So if I write these processes, P1, P2, P3, P4, arrival time is 0. 0. Now, in order to find what is the average waiting time, we must know what is the Gantt chart. So I am just drawing the Gantt chart with the help of SJF algorithm. So first of all, we need to select the shortest one. So P4 is given. It is taking from 0 to 3 millisecond. Then we need to pick P1 because the next shortest is P1 only. So 3 plus 6 is 9. Then we need to pick P3. P3, 9 plus 7. 9 plus 7 is 16. And then at last, I think P2 will come. P2 is 16 plus 8. P2 is taking 24 millisecond. So guys, if I write here burst time, so burst time is given P1 6, P2 8, P3 7, P4 3, right? 6, 8, 7, 3. And then we have a completion time as for P1 9, for P2 24, for P3 16, for P4 3, right? Now, first of all, in order to find waiting time, we are calculating first what is turnaround time, which is nothing but completion time minus arrival time. So 9, 24, 16, 3. Now, this is the right time to calculate what is the waiting time for individual process, which is nothing but turnaround time minus burst time. So 9 minus 6, 3, 24 minus 8, 16, right? Then 16 minus 7, 9, 3 minus 3, 0. If we add it, then 16, 3, 19, 19 and 9, 28, right? 28. So this is the summation of waiting time. We have to find average waiting time, 28 by 4. It turns out that 7. So I believe option B is the right answer for 92 question. Next is 93. It is saying the processes that are residing in the main memory and are ready and waiting to execute are kept on a list called the ready queue. All know. Then this queue is generally stored as the data structure of this particular ready queue is nothing but your priority queue. Okay, that means option B is correct. Then the last, probably the last question from OS. When a process create a new process using the fork operation, which of the following states is shared between the parent process and the child process? We all know that stack heap, the process is not going to share. Only the shared memory segment have to be shared, right? So the right option is D for this particular question. This is all about the OS part. Next, our colleague sir will take care of it. Thank you.
Right, I'm here to discuss about these electrical materials for ESE 2023. Now the question here, it is a numerical question. They asked the question related to the total net or net charge in a crystal. How can we find this total or net charge? Actually any one of the charge into that volume, right? So here 1.25 into 10 power minus 12, actually this is the total volume, we can say meter cube, with a charge that is 1.6 into 10 power minus 19, right? And also the volume density is given, right, into 10 power 25, right? You will get in terms of total coulombs. This is the total net charge. Here you should not consider, you should consider either negative charge or positive charge. Only one charge you should consider. So by solving this you will get 2 into 10 power minus 6 coulombs. So D is the correct answer for this question. D is the correct answer for this question. Now the next question, it's a very simple question. Which one of the following quantities is a material parameter? So material parameters are like electrical conductivity is one of the material parameter here. See, this is a property of material, right? Property of material, thermal elongation and electrical elongation. These are peridynamic lattice constant. These are different material constant values. So electrical conductivity is a quantity of the material. Now here, this is related to rock salt structure. So in this case what they are saying, at every, like in 3 dimension, positive charge ions occupies at the corner of the cube and as well as the center of the cube, center of the face center of the cube, right? So it is actually in a rock salt structure, especially in sodium chloride structure, the sodium atoms are occupying at the corners and face center, so that rock salt structure is the answer for this question. Now the next is the electrical conductivity depends on, the electrical conductivity sigma is equal to Ne mu, that depends on the number of electrons per meter cube and the mobility of an electron. So here volume concentration of electrons of conduction and their mobility. So B is the correct answer for this question. B is the correct answer for this question. Now another question, the classical theory of diamagnetism of the bonded electrons in free atom was elaborated by Larmor diamagnetism. B is the answer for this question. Right. Another one, which one of the following is the process of heating a material just below the melting point? See, actually sintering is the process in which we are heating the material up to just below the melting point temperature of the material, and then after that we are compressing. It's a powder metallurgy process, so A is the correct answer for this question. Right. Another question, this is the material used in electrical traction of high breaking power. Electrical traction of high breaking power. We are using steel material, copper, aluminum, this type of material. Here we can also use silver, aluminum we should use, copper we should use. Here aluminum is not there, here aluminum is not there, here aluminum is not there. So A is the most appropriate answer for this question. So A is the most appropriate answer for this question. And another question, which one of the following is the element exhibiting antiferromagnetic material? Iron is a ferro, nickel is a ferro, cobalt is a ferro, chromium is antiferromagnetic material. So here C is the correct answer for this question. Now the next last question, the electro-optic devices that emit radiation of different colors. See, remember, emit radiation of different colors, that is LED lights. LED light emitting diodes are used to generate different colors with the emitting radiation. So these are the questions related to electrical materials. Next our colleague will continue the session.
Mic? Okay. Right. Let us see the questions given in communication systems in electrical branch. This is the first question, spectral efficiency of 16 QAM. So M is 16, so N should be 4, so it will be 4 bits per hertz. Simple question, direct bit. What is the value of Q for a band pass filter operating from 800 hertz to 1200 hertz? So this is not related with the communication, I will pass on to the remaining part. An AM broadcast transmitter 10k watts and power is given to you. So here you can directly use the formula PT equal to PC into 1 plus mu square by 2. So substitute all the parameters. So he is saying 10 kilowatt is the radiated power, power taken by the carrier you have to find out, 1 plus 0.36, 60%, so 0.6 is mu, 0.36 mu square by 2. So if you do the calculation, you will get its value as 8.47 kilowatt. So that will be the value of PC as 8.47 kilowatt, right? Next. A PLL FM detector is used. He has given a KF value and a deviation is given to you. What is the RMS output voltage? So basically what you have to do here, you know delta F max is KF into AM. So the value of delta F max is given as 75 kilohertz and KF value is 100 kilohertz per volt into AM, peak amplitude of the message signal.
So you will get directly AM value as 0.75. Now the question he is asking is RMS value. So because it's a sinusoidal, this value you have to divide it with root 2. So that comes out to be 0.53 volts. So this will be your correct choice. Okay. Next, signal power and noise power at an input of amplifier are measured, and similarly they are also measured at the output. What is the amplifier noise factor? So amplifier noise factor is nothing but signal to noise ratio at the input of the receiver divided by signal to noise ratio at the output of the receiver. The ratio of these two things will give you the noise factor. So just substitute the value, you will get it as 2.66. That's it. Next. He has given a probability of occurrence of these source symbols. What is the source entropy? Entropy is a summation px into log of 1 by px. So depending on the number of symbols you have to extend this. So if you just keep on extending, means 1 by 2 into log of 2 to the base 2, log 2 to the base 2. Similarly, then you are having 1 by 4, then log 4 to the base 2. If you keep on extending on all symbols, the value that you will be getting here is 1.875 bits per symbol. So your correct choice will be option B. Next. What is a modulation index? If Vmax and Vminimum, Emax and Eminimum are nothing but the values of Vmax and Vminimum. So it is a difference of these two, 150 millivolts minus 70 millivolts by 150 millivolts plus 70 millivolts. So the value of the modulation index comes out to be 4 by 11. So approximately it is 36.4% in terms of percentages. Next. Here a receiver has a noise power bandwidth and it is operated at a room temperature of 30 degrees. What is the noise power contributed by the resistor? So noise power formula, you know, it is equal to Kp into B. K represents Boltzmann constant, T represents noise equivalent temperature in Kelvin, and B represents the bandwidth. Bandwidth he has given as 12 kilohertz. Substitute all the parameters, you will get a 4.636 into 10 to the power of minus 17 watts. So this is the right choice. Simple question directly based on the formula. Next, similar model only, 42. Amplifier has a bandwidth of 4 megahertz with 10 kilo ohms as the input resistance. RMS value of the noise voltage at the input of the amplifier. So RMS value of the noise voltage is given as root 4 kTB into R. This is a formula. Okay. Now KT is a standard value. When you take a T as 27 degrees, he has given 25, that does not make much of a difference. You can simplify this as 0.13 into root B into R. B represents your bandwidth or 4 megahertz which he has given, and R represents the 10 kilo ohm resistor. So if you substitute these parameters directly, you will get a 0.26 into 10 to the power of minus 4. Multiply with 100 and divide with 100, so approximately you will get this option C. Clear? So this, if you can remember, you can straight away substitute the values and get the answer quickly. That is how you have to save some time. So these are the questions coming from communication systems. So with this, we have come to an end of this live session discussion on questions given in electrical paper. We hope you have all done very well in your examinations, and we will separately give you a full-fledged key in the coming days. Thank you very much. All the best.